all kinds of stuff, but it's mainly based around Linux, Java, automation, cloud, and kind of focused on operations, although we also have a development chapter. You can always email me, GitHub me, link me. I don't have Twitter. Don't ask me why, I just never got into it. The Netherlands, for you guys who don't know where it is, it's everywhere, at least to XKCD. These are our future expansion plans. All the rumors you hear about the Netherlands are completely true. We ride bikes, we wear clogs, we're pro-choice, we smoke pot, and we produce trans DJs. And we love to do it all at the same time. So a little bit about me specifically. I come from definitely an ops background. I'm not a programmer. I don't write code for a living. So the code snippets and examples you're going to see, they're probably going to be horrible and full of mistakes. But as everyone noticed, even Puppet Labs prints wrong code on their t-shirts. So that's not a big problem, I think. Even more, someone asked me once, am I like a hardcore nerd ops guy, or am I more like a helicopter view, high over guy? And that was actually a pretty good question. And my answer to this was, I am a helicopter type guy who does a very good nerd impression. So if I can't answer your questions on very deep technical stuff, and we're going to get pretty deep, then I'm probably going to have to Google it, or you're going to have to Google it yourself. So last warning before we really start. I tend to ramble a bit. I tend to get off on tangents and get over enthusiastic and probably run out of time way before I finish my talk. If I tend to ramble too much, just raise your hands and get on with the story, because we only got 40 minutes. I actually wrote my whole presentation down. I never do that, so I hope it all goes well. Before we really start, all the stuff I'm going to show you, I didn't make that up by myself completely. There was a team behind me working with me, my colleagues, people at our client, really nice guys, guys from Amazon actually delivering support. So this is not like a big praise song about how good I am. We did it with a bunch of people. Okay, let's go. The company I worked for before I went to Xebia got an assignment from a client. We were already running stuff for this specific client on Amazon, basic web service, pretty basic stuff. And this client said to us, we want to take it a notch up. We want to put more stuff on AWS. This client actually asked me to not name their name because of security reasons, of course. So we're going to make up a fictional company, and the nuclear ice cream company. They make ice cream, but they use nuclear technology. So you don't want falling into the wrong hands. So everything needs to be very secure. And that's completely possible, of course, on AWS. And AWS is actually, out of the box, pretty secure by itself. And I put up a list right here. Let's see. I'm getting ahead of myself. There's the rambling part again. The assignment we got was build us a general purpose VPC on AWS. Well, building a VPC is not that hard. You can do it in a couple of hours. But that was just one part. The second part was make application deployment in this VPC standardized. Of course, because of cost and predictability and all that kind of stuff. And the third thing here was where our hair started raising. They wanted us to apply their company security policies to AWS. I'm reminding you, this is our nuclear ice cream company is a fairly old school company, but they're kind of like interested in new stuff. But all their stuff was hardware, Oracle, big IBM systems, WebSphere, you name it, they had it. Very much a traditional kind of shop they were running. So for them, this was kind of, kind of risky. So they had like a stack of paper which described their security policies. And well, we had to roll them out on AWS. So cool. They also asked us, do it with open source, because they were basically fed up paying Oracle, IBM, etc. Tons and tons of money every year for, stuff they could also do with Tomcat. I mean, why pay WebSphere if you can run it on Tomcat? So they also wanted us to stay very close to AWS standards, so use as much as there already is in AWS. Don't start inventing your own wheel, etc. Well, it makes sense, of course. And stay as close as you can get to reference implementations. So support can be more easy. You can make use of community contributions, etc. Well, that's all very well. And that was basically, in a nutshell, what we had to do. Maybe one more thing. The VPC that we had to build was a general purpose VPC. So it's like just a data center in which all kinds of applications could be put in from completely different business domains, like CRM, business intelligence, corporate websites, intranet websites, customer benefit applications, all kinds of stuff. Not specifically related to each other, but the only thing they had in common was there were web-based applications and some web server, some app server, some database. I already mentioned that AWS is actually pretty secure by itself. If you look at this list of acronyms, they got it all. They got their IAM user and rights management, multi-factor authentication, hardware service modules. It's all SSL, SSH, VPN, you name it. They got their certifications, their ISO 27001, payment card industry, DSS, PGP. They got everything. So, what are you going to add to it? What's going to make it more secure? Well, basically, two specific things. There are more things, but I got 40 minutes, so I picked out two things that we really rolled out and you don't get from AWS. And the first thing we did was build, of course, the VPC. I'm going to go into that a little bit. Then we're going to go into the hardcore stuff. Actually, before I go any further, you guys all use AWS? Are you all users, or guys that have no idea how it works? Because I'm assuming a bit of prior knowledge. If something is in the presentation, and you're like, I have no idea what that is, just raise your hand, and I can probably help you there. So some of the basic design principles. We didn't build anything really tough or hard or spectacular. What we did was use the availability zones, of course, that are in AWS. So use all three. That makes sense. Then overlay it with a couple of subnets, so you can create your basic three-tier stack: web, app, data. Easy. And one separate management subnet for our own tools and goodies, like the Puppet Master, your Puppet DB, Nagios, Greylock, all that kind of stuff. So what does it look like? Well, like this. Is it readable? Well, a bit. What you might notice is that you get, if you roll out your subnets, and I took out the IP addresses because, security, and what you get is like a 3x3 grid. You get 9 sectors, and that kind of helped us later on in determining where what should land. And you get like a tiny chessboard, 3x3 chessboard. Next to it, we built a little management subnet with your basic stuff that you use managing. There's also a Bastion host in there somewhere, but sure.
You only had one subnet for your management stuff?
Yes.
It's not highly available, right?
No. You're very right.
And also only one region?
Yes, it's all in the EU region, and this had to do with government policies and all kinds of stuff. We actually did push some stuff to US regions, but that was more like our own stuff that didn't have maybe traces of customer data in there. So that was the basic reason. Maybe something else I should say up front. Things like scalability were not an issue in this job. We were running this for a very well-known user group. We didn't expect it to scale. Like maybe the biggest app we deployed there was three servers, and they're like, I don't know, the X1 high mem servers, 3 of them, not like hundreds of thousands. I heard that guy from Microsoft telling they had like, I don't know, 10,000 instances running. Like, oh my God, no, we never even came close to that. So it wasn't about scale, it was about security. And it also actually wasn't about high uptime, because the applications were not their main business applications. So we kind of figured like we don't need to have 99.9999999% uptime, because it basically just gets too expensive. So we laid this out. This is where we started. And you have this, and then it's empty. You have an empty VPC. You have an empty network with nothing running in it except our management nodes. So because we had to stick to standards and had to make it reliable and predictable, etc., we started thinking, how do you roll out predictable stacks in your VPC? Well, of course, you use CloudFormation, because that's designed for building stacks in a predictable manner. One little piece of JSON, or actually 1,200 lines of JSON, and you can roll out whatever you want. So that's basically what we did. Together with our client, we designed, I think it was 7 different stacks. A web server with an app server, maybe a redundant, or maybe it doesn't even need a web server, or maybe it doesn't really need a database running on RDS. So we kind of drew up a couple of variations, and we designed these stacks in CloudFormations, and I'm going to be showing you guys some of that later on. Let's see if I missed something over here. No, I'm actually pretty good on track. Yeah. So maybe just a little thing to show in the image I was seeing. What you see right here is, of course, we had a database, a private, and a public. The public zone, which is 3 subnets, were the only zones that were connected to the internet. Kind of makes sense. The private layer, well, it's private. You couldn't access it from the internet. You had to use the company VPN to get in, because we connected the VPN from the nuclear ice cream headquarters, all the way from Iran, all the way to Amazon in Ireland. This actually works out of the box. You can get this stuff running like in a day, and it works, which is crazy. It's really amazing. I think that you can get that stuff up in a day. But CloudFormation. Who's using CloudFormation at the moment for stuff? 1 person, or 2, 3 or more. Okay, cool. CloudFormation kind of gets a bad rap because, JSON, it really sucks having to do it in JSON, but it's still like, oh, I'm 1 sheet ahead. There we go, no. There we go. It kind of like, it's incredibly powerful, but it's also incredibly cumbersome working with it. We'll come back to this later. Just to give you an idea, this is a file name, which doesn't mean anything, of course. I'm going to switch to my little thing here. This is an example of like one of the CloudFormation stacks that we used to deploy a predefined standardized stack. It's pretty long, 1901 lines of JSON. Great. 1 typo, 1 comma wrong, and you're basically screwed. But still, it's incredibly powerful. And what actually never gets old, and I'm switching back to my presentation now, what never gets old is once you build that 1900 line JSON thing with all your databases, subnet disks, load balancers, etc., it's all there. You fill out the input parameters, you press enter, you go get a coffee, and you come back, and your whole stack is deployed. It's a redundant 3-tier system with all the security and all the checks and balances that you want. It's there. Actually, if someone would have shown me that 10 years ago, I would have probably started crying or maybe accused them of witchcraft. It's really, and burn them or something, I don't know. It's really, I take it for granted now. You can kind of get used to it, but it's ridiculously powerful that you could just build a little piece of JSON, press some buttons, and whoop, there it is. Three-tier system with an Oracle database, etc. It's kind of crazy, but we tend to forget that just, it's come a long way. So, in a little image, how did the whole thing work? Well, template gets filled with parameters. We used, for our EC2 instances, we always used the standard AWS Linux AMI. We didn't really find a reason to use anything else. You could get Red Hat or Ubuntu or whatever. We just used AWS Linux, which is, I think, 99% Red Hat, just without the licenses. And well, you boot up your template, which turns into a stack. And each EC2 instance, which is just one part of the template, of course, because we were also booting up RDS databases, creating ELB load balancers. That EC2 instance gets started, and then magic happens with your user data that you input into the instance. And after a while, a completely hardened EC2 instance rolls out, which talks to our Puppet master, which is great. And but what does it really mean, the hardened EC2 instance? Well, how much time? 24 minutes. Cool. I'm going to show you two things. There was more, but this one was pretty cool. What they came up with for us was we would like to have our Linux images or instances hardened according to the Center for Internet Security benchmark for Red Hat Linux 6. We would actually like you guys to log or alert in some way any discrepancies that there are there. And you also have to monitor anything that comes through the yum repos, like security update, kernel patch, whatever. The last one was pretty easy, but I don't know if you guys are familiar with the Center for Internet Security benchmarking stuff. It's pretty cool stuff. They'll have like a huge list of stuff they benchmark, and some really nice tools for it also to check whether your running Linux instance is actually hardened according to their spec. It's 140 pages of stuff, like do this service should not be running, this user should not be there, this SSH module should be configured in this way. And what we did was we took the benchmark and built it into a Puppet module, because almost everything that's in the benchmark is especially fitted for Puppet, because it's already written basically in Puppet, but then in natural language, like never run this service. Make sure this user is disabled. Make sure this file is always there. So it's almost Puppet-like. So we started building it, and we just used the chapter layout that's already in the document, and we just got coding. Some of it is really simple, and just some file definitions. This is, some limits.conf, which says something about where core dumps should go, and well, just use basic Puppet structures to get it done. Some file line replacements. Here we did something with kernel exec shield is 1. Yes, that's very important according to the benchmark. So that's great. It's really easy. 90% of all those benchmark rules you could get done in, but there are a lot, a day or two. But some stuff gets a bit harder, and I don't know if you're familiar with the PAM stuff. It's like authorization modules you can plug into your Linux stuff. If you replace a file that's part of the PAM package, your Linux will basically freeze up. It doesn't like it. You can't just open up the file in VI and you have to do it differently. So what we did was we used Augeus. And I don't know how many of you guys have played with Augeus in Puppet. It's kind of sucks, as in it's really difficult and you kind of like not know what you're doing. I mean, if you look at this code, this just basically replaces 2 words in a file. That's kind of a lot of code for replacing 2 words, but this is very necessary. And I'm actually looking forward to a talk by Greg from Rackspace that I met yesterday. He actually wrote an Augeus provider type, which kind of shields you from all the difficult Augeus stuff. And makes it more easy to use AWS in a different way as a types and provider type. I'm actually pretty excited to start using that, and I wish he had that stuff done 6 months ago. That would have saved us a lot of work. So I'm rambling again. Where did this end up? Well, this ended up in a big set of documents which we tagged with all kinds of rules, and we checked whether stuff was running. If stuff was not running or was not according to the benchmark, we would log something in syslog, and then we would know it because oh yeah. One thing about tags, I don't care what they say at Puppet Labs, but order is important, very important. I mean, we had some real major issues when lots of Puppet types and resources start piling up. You can get into really crazy situations. We were running Puppet 2.7, so I'm not sure if some of this order and tag stuff is maybe fixed in later versions. Okay. We have a Puppet run. We have our benchmark module. It's running, great. It's checking all the stuff like, is this rule applied? Is this file there? If something happens like, oh, no, it's not, then we record a log statement and we push it to syslog, and we connected syslog to Greylock 2, which is awesome. I love Greylock 2. And well, of course, you can see here how that works. Pretty easy. You put your Greylock 2 host IP address in Hiera, so we could basically point it anywhere. And if the company bought like a real logging system, we just change the IP, and there it goes. And at the end of the day, what do you have? Well, you basically have something like this, which is just Greylock. That's nice. You can look up all the statements and stuff. But you can also start trending and sorting and alerting and graphing on this benchmark. So everything that gets applied, everything that doesn't fit to the benchmark or is wrong, you can alert on it, you can graph it, and you basically have a security incident module application for $0. It's not like completely, there are some really nice appliances you can buy, but this does a lot. And it adds a lot to making sure that your images, your instances are running securely, and it's verifiable, auditable, trackable, and alertable. One thing that's really nasty though is that I would love to open source this Linux Red Hat 6 security module, so anyone could download it and harden your machines just by doing include baseline module. At the moment, I'm not allowed to because this was built on someone else's dollar, and the ice cream company is not that supportive of. They know the value of open source, but they haven't made the step yet in contributing to this. If the guys at the company watching this video, maybe later on, give me the okay, and then I'll put it on the forge, and then we can all have very secure Linux images. That will be really cool. Okay, I'm rambling again. Second topic, what did we do? Network traffic logging. What does Amazon give you? It gives you firewalls, as in security groups, network ACLs, at least you get them in the VPC, and it basically does what it needs to do. It filters and rejects traffic that you don't want and allows traffic that you want, but it doesn't log anything. This was an issue. We needed to log all traffic going in and out on any level of the whole VPC. So what do? You could buy a very expensive appliance, but we have to do it with open source and stick to baselines and use whatever it's there. So you use IP tables. It's on every instance, it's always running, it's part of the kernel, it's very fast. So that's really nice. We already had the Greylock 2 thing going, so why don't we hook it up into that? So that's basically what we did, and we just took the standard Puppet Labs Firewall module, which is an IP tables module, and tweaked it a bit. And I'm going to show you some code. Just what we did was we want to allow or drop connections. We want to tag connections that are initial, not your established connections that are already running, because we don't want to run everything. We just want to log all the initial connections. and then we dump it all to Greylock. So what does it look like? First, you build your firewall module. You take your Puppet Labs firewall module and you start building chains. I don't know if you guys are familiar with IP tables. It's really nice. It's just a bit like, I don't know if ancient is the right word. It's very powerful, but you really do need the man pages to be really sure that you do the right thing, because otherwise you lock yourself out and you have to kill the instance and do it again. And that happens quite a lot of times when you're building stuff like this. What you do is you define rules and you define chains of rules. First one, allow related traffic and established traffic. So stuff that's already running, let it pass through. Don't do anything with it. It's fine. Next one, define some chains. And what we did, we just basically created a chain called LogMu. And we routed all the traffic that's allowed and initial, you route it to this LogMu chain, or you jump it. That's the IP table term. You jump it and you tag it. Tagging is basically, it just adds literally a string in the packets of the traffic. When that's done, when it's tagged and chained, we jump into the log destination. This is a built-in IP tables thing. But it just logs it to syslog, and that's it. And then we accept it. That's the next step. So it comes into the new rule, tag it, log it, and there you go. You're allowed to enter the network, which is great. And we, of course, did the opposite for stuff that we don't want. And so what does it look like? Well, you're port 22, or SSH. We want to get in for SSH. Well, you define your firewall rule. This is number 100, so it's right on the top. State is new, as in it's a new connection. Destination port 22, of course. TCP protocol, and send it to the LogMu chain. The LogMu chain then does the rest. And we had some exceptions to this. And that's when it always gets difficult. It works for 99%, and there's this couple of edge cases, which are pretty important, and they tend to break down. So there's always proxies, there's always DNS servers, there's always nodes that are performing some kind of bridging function, and they're just slightly different according to network traffic. And we had to create exceptions for these, and you don't want to do it manually. That sucks. I mean, we have Puppet. Why should we do it? Like, why should we have to look out for, this might be a type of kind of bridging node. Let's change the code. So we built some just to recognize whether a specific node was a bridging node or a proxy node. We could recognize it by its location in the VPC, as in what subnet the node was located. And you could do some really easy stuff with factor. So we wrote 2 custom factor facts, which are incredibly easy and are incredibly dirty. This is probably really horrible code. It's just a big regex thing in Ruby, and it just looks at the IP address. And because we defined the subnets ourselves, we could see at the look at the IP address and tag it like, oh, you're in zone 1B, or you're in zone 1A, and you're zone 1C. Oh, that's a management node. So we tagged it and wrote a little factor fact. Pretty easy, works like a charm. We did the same for tiers, because we could see like, oh, you're in the 3 range. That means you're a public web server, or you're in the public network. Together with these facts, we could call these facts in our Puppet modules. It's like, oh, this node is in the public zone. It needs slightly tweaked IP tables config. Works like a charm. And then you're done, basically. This is a day of coding, maybe. Just basically bug fixing, a little bit of tweaking, making it look nice. So it's ridiculously simple, actually, but it's very, very powerful. We already had Greylock 2 set up, tweaked IP tables, and log messages started streaming into Greylock, and we could arrange them, make some streams out of them, and you really have a pretty nice network monitoring tool, which you can alert on, do some analytics on, make backups of, etc., etc. How much time do we have? 11 minutes, cool. So that's all fine and dandy. This is always the best part, of course. This is why I come to conferences like PuppetConf. I always want to know what sucked, what was really cool, and what was really, really horrible and kept you up at night. Because it kind of makes sense to share this kind of stuff, because it would be horrible for you guys to fall for the same traps or get into the same problems that we did. What's very good? Community, really nice. I think 99% of the code that we wrote, it's tweaks from code that's already there. We didn't have to invent our own system. We didn't have to invent our own structures. It's already there. The blogs and the Puppet Lab site is very good and provides you with everything you need. It's basically only the obvious things, as in tweaking little security files somewhere deep in the Linux system. That was kind of hard work, and it tends to go wrong a lot of times. But that's basically it. So the community really, really helped. Greylock too, I can't say enough of good things about it. It's just simple, it works, it starts up, it's really fast. We were putting in millions and millions of log messages, and it was running on a pretty modest system. It wasn't like a huge clustered thing. So yeah, really cool stuff, and it's free, it's incredible. What's also good about AWS, VPC? Well, recently Amazon actually made VPC the default. So if you start up like a normal on-demand instance right now, it actually already is in a VPC. You know, I think you just have to push one button somewhere, and it actually is in a real VPC you can manage. So VPC is definitely the way to go. I don't really have an idea why you would not use it. And it's easy. You just click some stuff and you have a network. CloudFormation is, or I already mentioned it, it's incredibly powerful. I don't really have any other examples of a scripting language, a real scripting language, or JSON code then, that allows you to do this kind of stuff on cloud platforms. Sure, there's APIs, there's command line, there's REST interfaces, etc. But this is way more sexy. You don't have to call anything. You just write the code. It's infrastructure as code done properly, except for the JSON. And I really am still quite amazed by the power of it. So what's bad? Remind you, we're running 2.7, so some of this might have changed in the newer version, but performance of Puppet runs could be a big problem. The 9 pages of benchmark rules, that was quite a lot of stuff going on there. If you boot up a smaller node, micro instance, I don't even think it would work. It would just run out of memory. But it gets slow, really slow. So we put in some really basic tweaks. We had to do some recursion on directories, as you can see here. Get rid of the checksums. We didn't need the checksums on files. If you're like a big directory or folder or tree, it gets really horrible with checksums, and your CPU starts pounding. And ignore stuff like log directories or temp or work directories, which are all full of cached files or stuff like that. You don't really want checksums on some Tomcat work directory. Why would you want that? So ignore them, and it saves you a lot of CPU cycles. Underneath there, Hyra. I love Hyra, works great. We use it all the time. It's just in a security environment, you need passwords, of course, and these passwords have to be encrypted. That's where Hyra GPG comes in. At least that's what you can find on the Puppet Lab side, but it just basically sucks. It's way too cumbersome. It doesn't really, it works, but it doesn't really get you along. It slows things down incredibly. It just sucks. They should come up with a better solution to it. But eventually, I think we switched to an MySQL database for a backend to Hyra, and you could do some more fancy stuff with encrypting stuff. But it sucks. Okay. Well, I already mentioned this. JSON notation in CloudFormation is just, you can't put in comments. I mean, why? It's crazy. They should really port it to something like Ruby or something. I don't know. There's actually a guy working on CFN DSL on GitHub, which is Ruby DSL for CloudFormation. You type in Ruby and you run it through some script, and then poof, out pops a little template in CloudFormation. I think it's a bit buggy, but it's a really nice way of doing it. And I think the guys at Amazon should buy this and do it this way. I hope someone's here from Amazon. So, last 6 minutes. I promised myself not to go into a rant, but I'm actually gonna go into a rant anyway. What's really ugly, and what you start noticing if you're booting up lots of instances on AWS and managing them with Puppet, is that you get drift in state and lifecycle. This is something which really becomes a really big issue after a while. There's no unified system to know the exact state of everything. You have your Nagios here. It says the instance is running. You have EC2 there, and it says, oh, it's also running, but this one is not running. Then you have Puppet, and it says, yeah, the node is defined. Once you start switching things off and on, it starts getting really hazy. Like, is my Nagios check failing, or is the Puppet manifest not running, or is the EC2 instance down, or all three, or one of the three? I don't really know. And you start running around in circles, and you start to get unsure. Like, can I trust my monitoring? Can I trust the EC2 instance status using, I don't know, some REST core or just the GUI? It's really a difficult problem because Puppet and AWS, they're different worlds. They don't know each other. They have no connection. Of course, I know there's this thing you could boot up EC2 instances from Puppet, but that's just EC2 instances. We were using way more than EC2 instances. We were using everything that's on AWS. It's just a small part of the whole system. And the whole system has a different DSL. It has different authentication and authorization stuff, different users, different keys, different paradigms even. You're just using a different way of looking at reality. The versioning is different. Everything is basically just kind of looks the same, but it's not the same. So after a while, I kind of started rambling and getting angry about this stuff because I want one single source of truth for everything we're running. I want an audit trail and logging that logs everything from beginning to end. So what I do in Puppet, what I do in EC2, or in some other AWS service, I want it to be one stream of log files. I logged in, I created a new class in Puppet, assigned the class to the node manifest. Then it started up an EC2 instance which got connected to an ELB, and I have the rights to create ELBs, and then I want it in one stream. It doesn't exist at the moment. Or actually, some of the companies walking around here say it kind of exists, and they're building it at the moment, but something like a CRUD model, create, read, update, delete, on the whole infrastructure would be really, really great. So, what are these companies that are saying yeah, we're actually doing that? You have your right skill, you have Scalar, the guys walking around here, you have Cloudify, AWS OpsWorks kind of does it does it with Chef, but that's okay. Is this the solution? Well, I've looked at all of them and kind of worked a bit with is it pronounced Scalar or Scholar? I don't really know. Scholar, maybe? I don't know. Yeah, it kind of does it. It kind of brings you automation on an infrastructure level and on an application level. It kind of mixes it together, but it's not quite there yet because it's too far away. It doesn't provide me enough detail. I want Puppet to I want to edit the tiny nitty-gritty. I want to be able to do the tiny nitty-gritty things on AWS. I don't want a layer of sauce on top of these two different systems. And we provide you with some stuff, and you can click some stuff, and it kind of works. And I don't want it to be a third-party vendor. I don't want it to be some kind of watered-down version of what's the actual product. So, yeah. Is there hope? I hope so. I think Puppet Labs just recently acquired Cloudsmith, which does a little bit of stuff on Amazon. You can do lots of stuff, and it's also, now it's owned by Puppet. Maybe something's happening there. So yeah, that would be really cool. And if we could get like cloud provisioning, configuration management, and application deployment in one really unified piece of software with one nice CRUD model, I would be very happy, and I will buy you an ice cream or something, I don't know. My rant is over, and we've got 1 minute left for questions. Thank you. Any questions? Sure.
I have a couple of questions. First, what storage did you use in your VPC?
Sorry?
What storage system you use in your VPC?
What kind? Sorry.
So you use S3 or EBS volume storage?
Oh, storage. We used everything. We used mostly EBS for just the disks, because actually one of the sys benchmark rules is that like your TMP file system should be on a different disk. So we actually had to do some trickery with the LVMs, the logical volume managers, that once we booted up an EC2 instance, it would shift around the disks, and then it would mount /TMP on a different EBS volume. But for all kinds of other stuff, we definitely use S3.
Because in the S3, you mentioned you're very confined VPC, mostly use the EU.
Yeah.
But if you put stuff in the S3, it can replicate different regions.
Yes, that's exactly true. Yeah, that's why we use it like for static files for websites, like images and all kinds of stuff, which didn't really have any security rating to them. They're public. So we only use it for public stuff. That's definitely true. Yeah.
The second question was, after you apply the CIS benchmark
Mm-hmm.
on the AMI, you hardened it.
Yeah.
Hardened means that you build the image out of it, or you just live system, you just Puppet used to control.
We actually started by booting up a Linux AMI and then applying the benchmark and then snapshotting it, like, okay, there we are. That's our hardened AMI, fine. But what happens if like the benchmark changes, or someone logs into the system and like, oh, I can't do this because of security. Screw it, I'll just change it. So we kind of went off the model of snapshotting a hardened image and just start always with the default Linux Amazon image, boot it up, apply the benchmark, and apply that benchmark every half hour, which we actually kind of scaled it down to once every day because the performance was too much. One more question? Oh no, it's done. Please come up to me after the talk and we'll discuss everything, because I'm out of minutes. Okay, thank you.